everyone. Today our chapter is periodic table, periodic properties and variations of properties. In this, we are going to know about periodic properties such as atomic radius or atomic size, metallic and non-metallic character, ionization potential is also known as ionization energy, electron affinity and electronegativity. Okay. First, we will know what is periodic properties. The properties of elements which are directly or indirectly related to their electronic configuration and show a regular gradation as we move across a period, that is from left to right or down the group, that is from top to bottom, are known as properties. This is the properties of elements where there is a relation with electronic configuration of the element and they show a changes when we move across a period and from top to bottom down the group. Okay, now we will know what are the important periodic properties. The important periodic properties are atomic size, non-metallic and metallic character, ionization energy, electron affinity and electronegativity. First we will know meanings of all the periodic properties. Atomic radius. Atomic radius is the distance between center of the nucleus and the outermost shell of the atom. Okay, in this picture you can see here, this is the center of nucleus and this is the outermost shell of the atom. The distance between these two is known as atomic radius. Okay. Then comes the ionization energy. Ionization energy, it is the amount of energy required to remove the outermost electron. Okay, the energy required to remove an electron which is present in the outermost shell of an isolated gaseous atom. This is ionization energy or ionization potential. Next, electron affinity. It is the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. Energy released when an atom in the gaseous, it is going to form an anion. That is known as electron affinity. Then comes electronegativity. Electronegativity is the tendency of an atom to attract electron itself when combined in a compound. If it in a compound, one element attracts, they have a tendency to attract the electron to itself when they are in a compound state. That is electronegativity. Here is an example, that is HCl, where HCl is a covalent bond. Okay, H and Cl, there is a small difference in electronegativity. Okay. Then comes non-metallic and metallic character. In terms of electron loss or gain, an element is a non-metal. How can we say element is a non-metal? If it gains one or more electrons, it is known as non-metal. If an element is gaining one or more electron, then it is known as non-metal. If an element it is losing one or more electron, it is known as metals. Okay. Now, atomic radius. Atomic radius is the distance between the center of the nucleus and the outermost shell of the atom. If you see, there is a picture also, there is the atomic radius is represented. Now, atomic radius depends upon two things. What are those? Number of shells and nuclear charge. Number of shells means if the number of shells is increasing, there is a more distance between the center of the nucleus and the outermost shell, and thereby atomic radius also increases. Okay. Then comes the nuclear charge. An increase in the nuclear charge decreases the size of the atom because the electrons are then attracted towards the nucleus with a greater force, thereby bringing the outermost shell closer. Because of the outermost shell coming closer to the nucleus, there is a decrease in the size of atom, that is atomic size is decreased. Okay. Then comes trends in atomic radius. See, we have to take down the group and across the period. First we will take down the group. In a group, the size of an atom increases as one proceeds from top to bottom. This is due to the successive addition of the shells. See, when you come from top to bottom, there is an increase in shells which increases the distance between the center of the nucleus and the outermost shell. That makes the atomic size also increases. So overall, from top to bottom, that is from down a group, the atomic radius increases. Okay, in this table also you can see as the number of shell increases, atomic size increases, and nuclear charge increases, atomic size decreases. Okay, then across a period, that is in a period the size of an atom decreases from left to right. Across a period means moving from left to right. This is because the nuclear charge. Why it is decreasing means because of the nuclear charge, that is atomic number increases from left to right. There is an increase in the atomic number in the same period, thereby bringing the outermost shell closer. Here what happens in across a period, the outermost shell comes closer because of the nuclear charge, and thereby there is a decrease in the atomic size. In this table you can see number of shells remains same and atomic size is unaffected. When nuclear charge increases, there is a decrease in the atomic size across a period. That is from left to right. Okay. Next comes, see in this picture you can see when you move from left to right, there is an atomic size decrease, and when you move from top to bottom, there is an atomic size increase. You can see the size of the elements also. Okay. Then comes metallic character. Those elements which have a tendency to lose the valence electrons. Valence electrons means electrons present in the outermost shell. Okay. Those elements which have the tendency to lose their valence electrons and to form a positive ion. They are losing electrons to make them positive. Okay. They are considered as metals. And one more thing, metals are reducing agents. Okay. Now, the metallic character of metals depend upon two things. One is atomic radius and one is nuclear charge. Atomic radius. The greater the atomic size, the farther is the outermost orbit. Yeah. What is the atomic radius? The distance between the nucleus and the outermost shell. If the atomic radius increasing, there is a more distance from nucleus and the outermost shell, which makes there is a lesser pull from the nucleus to the outermost electrons. As a result, electrons can be removed more easily from the valence shell. Why? Because there is a less nuclear pull. Yeah, that making metallic formation easy. Okay. Now coming to nuclear charge. The greater the nuclear charge, the greater is the force exerted by the nucleus on the electrons of the outermost orbit. This makes it difficult to remove the electrons from the outermost orbit. Thus, metallic nature decreases. What is nuclear charge? The nuclear charge is the electron pull from the outermost orbit to the nucleus. If this nuclear charge is more, then the metallic character decreases. Understood? Atomic radius increases, metallic character increases. If the nuclear charge increases, metallic character decreases. Okay. Now, trends in metallic character. Down a group, that is from top to bottom. On moving down a group, the atomic size increases and the nuclear charge also increases. The effect of an increased atomic size is greater as compared to the increased nuclear charge. Therefore, metallic nature increases as one moves down a group. Why? Because there is an increase in atomic radius, that makes metallic nature also increases. Okay, that is they can lose electrons easily. When moving from across a period, on moving across a period, the nuclear pull increases. There is a more nuclear pull due to the increase in the atomic number, and thus the atomic size also decreases. Here atomic size is decreasing, hence elements cannot lose their electrons easily. Therefore, metallic nature decreases across a period when moving from left to right. When coming to down a group, atomic radius increases, metallic character also increases. When you move from left to right across a period, atomic size decreases and metallic character also decreases. Okay. Then here you can see in this picture there is an increasing metallic character from top to bottom, and if you take from right to left, there is an increasing metallic character. Okay. Next, non-metallic character. Those elements which have a tendency to gain electrons in order to attain their octet electronic configuration in their outermost orbit. See, in any atom, the outermost orbit should have 8 electrons. So, to attain that octet electronic configuration, some elements have the tendency to gain the electrons. They are known as non-metals. And non-metals are also known as oxidizing agents because they have a tendency to gain the electrons. Okay. Now, the non-metallic character depends upon two things again: atomic radius and nuclear charge. Okay. Atomic size. The smaller the atomic size, the greater is the nuclear pull. Yes, atomic size is small, then the nuclear pull is greater. And the greater is the tendency to gain electrons, therefore the element is more non-metallic by nature. And then coming to nuclear charge. The greater the nuclear charge, the greater is the tendency to gain electrons. If the nuclear charge is more, nuclear pull is more, you can gain the electrons more, and hence more non-metallic is the element. Okay. Now, trends in non-metallic character. When coming to down a group, that is from top to bottom, the atomic sizes increases. Okay, why? Because due to the addition of new shells over successive periods. Though the nuclear charge increases due to an increase in atomic number, the effect of an increasing atomic size is greater. Therefore, non-metallic nature decreases down the group. Why? Because there is an increase in the atomic size. Therefore, there is a decrease in the non-metallic character from top to bottom. Okay. Here you can see there is an example: nitrogen, phosphorus, arsenic, antimony, bismuth. There is a decrease in the non-metallic nature. Okay. Next comes across a period. On moving across a period, the tendency to gain electrons increases due to an increase in nuclear pull. When you move from left to right, the nuclear pull is more. When the nuclear pull is more, we can gain the electrons more. Okay. Thereby, non-metallic nature increases across a period, that is from left to right. Okay. And when from across a period, there is a decrease in the atomic size. So, the metallic character is increasing across a period. For example, this is in the third period, that is Na, sodium, magnesium, aluminum, silicon, and this non-metals and all. See, there is a non-metallic character increasing. Okay. That's all. Yeah. Thank you.